So far, we learned to solve quadratic functions by graphing in those three forms, right? And the solutions are where it crosses the x-axis. Those are called the zeros. So we did it that way. We did it by factoring, which personally is my favorite way, completing the square and the square root property. So square root property only works when you don't have a b, right? So when you just have the a, the x squared stuff, and the c. So it won't work if you have a b. Factoring doesn't always work. You can always do completing the square. You can always graph, but they're not always the most efficient. We're going to learn another way with the quadratic formula, which I know you did in Algebra 1. I know it. I know it. And this works 100% of the time. And it's not terribly difficult. Your calculator does most of the heavy lifting for you if you'd like. But the quadratic formula, here's the formula for it. The x is the opposite of b, negative b, plus or minus the square root of b squared minus 4ac all over 2a. It seems complicated. It's the same procedure each time, so you'll have that memorized in no time. But I do want you to notice the 4 and the 2 are always in the formula. How did someone figure this out? I don't know. They're way smarter than me. It's impressive. Well done. Which it's not that hard to be much smarter than me. It sounded like I was bragging. Oh, how could anyone be smarter than me? I don't know. The discriminant is this portion of the quadratic formula. It's the part that's in the square root. And that can quickly tell you how many solutions there are. Because if that comes out negative, you can't square root negatives with real numbers, right? So there would be no real solutions, but there would be imaginary solutions like the complex number system with the i's. So if that comes out negative, no real solutions, 2 imaginary solutions. If that came out to 0, there's no such thing as negative 0. So this plus or minus part, so there would just be one solution if the square root comes out to 0. And if it comes out to any positive number, there's automatically 2 real solutions. So when they ask you about the discriminant, that's the portion they're asking you about. Let's see if I'm able to. Oh, I gotta extend the page. So here it is kind of shown in pictures for you. So this is saying if it's greater than 0, aka it's positive, there's going to be 2 solutions. It's going to cross the x-axis at 2 places. If it comes out to exactly 0, it's only going to hit at 1 place on the x-intercept. And if it comes out less than 0, it's going to be above the x-axis. So it never crosses the x-axis. So no real solutions, but 2 imaginary solutions, okay? And I'm pretty sure we have some of everything today. Extend the page again. All right, the discriminant. Now, we have to always get it equal to 0 on this one. A little different than completing the square. It has to equal 0 just like with factoring. So here we'd have to move the negative 2 to the other side. X squared plus 10x plus 2. Now your a is 1, your b is 10, and your c is 2. So if we did the b squared, 10 squared minus 4ac, 10 squared is 100. 4 times 1 times 2 is 8. So this comes out to 92. That's greater than 0. So if it said type and number of solutions, we'd say 2 real solutions. And yeah, I did that on purpose because I'm too real. That's 2 jokes in this video already. I'll give you a moment to calm down. I'm sure you're laughing hysterically right now. You good? We back? Okay, there's another one coming, so be ready. 1b, we got to get it all on the same side, so we'd have to subtract the 6x. We'd have to add the 9, and then let's figure out what b squared minus 4ac is. b in this case is negative 6, negative 6 squared minus 4, a is 1, c is 9. Negative 6 times negative 6 is 36. 4 times 1 times 9 is 36. 36 minus 36 is 0, and if it comes out to 0, that means there is one real solution. Which, yeah, I did that one on purpose too, because you guys know I'm one real. And then this one.
Gee, I wonder how this one's going to work out. We had two real solutions, one real solution. I wonder what's going to happen over here. Okay, let's see, b squared, so b is -1, minus 4ac. -1 times -1 is 1. 4 times 2 is 8 times 2 is 16. So this comes out to -15. So we would say no real solutions.
But we could say two imaginary solutions. Or complex solutions. Let's see what they say up here. Yeah, they say two imaginary. Use your imagination a little bit, okay? You could also say two complex solutions. All right, here it is. Now we're going to actually solve the full thing with the quadratic formula. Now the nice thing is, like, this is essentially a skeleton. We're filling in blanks in the formula. I put the formula on the slide over here. Opposite of b plus or minus b squared minus 4ac all over 2a. I'll tell you, when I think about some stumbles I usually see with students, one thing I often see is they forget the negative in front. It's always the opposite of b. So if b is negative, eventually it'll turn positive there because it's the opposite of negative whatever. Another problem I always see is students will just put the fraction over the square root stuff, but the fraction's over the entire thing. So the entire numerator, you handle that first, and then you divide by the 2a. Okay, those are the two I initially think of, because I see them constantly. So in our case, a is 1, right? It's always whatever's in front of the x squared. B would be 10, and c would be positive 2. So we'll drop them in. So opposite of b, b squared, 4ac, so a is 1, and then c is 2. Honestly, that's probably the hardest part, getting them in the correct space. Because you could rely on your calculator from here. You shouldn't need to. I mean, you guys are smart. We can do this. Opposite of 10 is -10. Plus or minus, and I'll tell you why that is in a few minutes here, but you probably can already think of why we have a plus and minus there. 10 squared is 100. 4 times 1 times 2 is 8. And then 2 times 1 in the denominator is 2. So I like to handle all the square root stuff first. -10 plus or minus 100 minus 8 is 92 over 2. In Algebra 1, you probably just took the square root of 92 and said 9 point blah, 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 and rounded to the nearest decimal. For us, the whole reason we practiced with the radicals is for exact answers. So we're going to look for a perfect square that goes into 92. So 4 definitely goes in there. 4 times 23. Square root of 4 is 2. So we have -10 plus or minus 2 root 23 over 2. All right. Now, the reason we have the plus or minus, just like completing the square, is because every square root has 2 roots, right? Positive or negative. So you got to set it up with the plus or minus. Now you could, again, actually calculate this. -10 plus 2 root 3 and then divide by 2. Great, that's perfect. Here's what I'd like you to do. I'd like you to kind of split this into 2 fractions, because we're going to be able to simplify part of this. So -10 over 2, right? This part over the 2, and then we have the plus or minus 2 root 23 over 2. Because sometimes you will be able to simplify part of that. Now, if you couldn't simplify part of that, You can circle that up, and that would be your answer. But we can simplify actually both parts of this on this problem. Negative 10 divided by 2 is negative 5, plus or minus 2 root 23 over 2 would just be 1 root 23. So this is our final answer in simplest form. That is an exact answer. That shows you both solutions, both real solutions, because it had a positive square root. Whew. The first one is the hardest. But as you guys know, like Jay Lawson said, this is why we play the game. You know what I'm saying? To be or not to be. That's the one. I wrote that joke months ago, just for this problem. You knew it was coming. You knew it was. Okay. Now this is a problem that you could factor, and you would get your answer much quicker than the quadratic formula. But we're going to practice the quadratic formula as a backup in case you can't factor something. So b, in our case, would be the negative 6, so that goes there and there. The a would be 1, which goes there and there. And then the c, in our case, would be positive 9. Great. All right, let's clean up some stuff here. The opposite of negative 6 is 6, plus or minus. Negative 6 squared is 36. 4 times 1 times 9 is 36. 2 times 1 is 2. 36 minus 36 is 0. No, what's the square root of 0? It's just 0, right? There's no such thing as negative 0. So this is just really 6 plus 0 divided by 2. Now 6 plus 0 is 6. And 6 divided by 2 would give us 3. So we only had one solution on this problem because the discriminant came out to 0. Now, if you were to factor that originally, that would factor to x minus 3 squared equals 0, which would give you x equals 3 right away. If you're good at factoring, look at the amount of work you save. Is every problem factorable? No. Some of them are. A lot of them are. 2x squared minus x plus 2. So b would be negative 1, 2. A would be 2. And c would also be 2. Let's simplify some stuff. Opposite of negative 1 is 1, plus or minus. Negative 1 squared is 1. Negative 4 times 2 times 2 would be negative 16. And then 2 times 2 is 4. All right, let's keep it going. 1 minus 16 is negative 15. Now in Algebra 1, you can't square root negative 15 because you don't really learn the complex number system. But remember, we can get rid of that negative in the root by taking the square root of negative 1, which is I. So this would be I root 15. Are there any perfect squares in 15? No. So we could write that as 1 plus or minus I root 15 over 4. Now, I want you to, in your head, separate these into two fractions and see if you can simplify either part. The 1 over 4 plus or minus I root 15 over 4. Can you simplify 1 over 4 at all? No. Can you simplify I root 15 over 4? No. So, if you know that, I want you to rewrite your final answer as one fraction. So, I know that seems crazy to separate it and then join it back together, but you can kind of separate it in your head sometimes. Like if you had 2 plus or minus 40 root 2, that's a bad example. Because 2 goes into 40. Well, I flubbed that one. Let's say you had 10 plus or minus 12 root 2 over 6. Great example, Mr. Plain. I'm glad you made this one up. If you were to separate each part of that, like 10 over 6, plus or minus 12 root 2 over 6, it goes into 10 and 6 too. So it goes into 10 5 times, 6 3 times. We'd have 5/3 plus or minus, and 12 root 2 divided by 6 would be 2 root 2. This would be the final answer I want instead of up here, because it can be simplified. And you could even look up there and be like, okay, well, 2 goes into all three terms. So it could be 5 plus or minus 6 root 2 over 3. And that's a better answer, but part of it can still be simplified. This 6 root 2 over 3 can still be simplified to 2 root 2. So I prefer separate either in your head or actually write it separate. And then if you have to recombine them, that's okay. It'll take 2 seconds. But check to see if you can simplify either part of that fraction. 2D or not 2. All right, B is 7. A is 1. And C is 10. Now, look at that problem. That's very factorable. Factors of 10 that add up to 7 would be 5 and 2. X plus 5 times x plus 2, which would give us x equals negative 5 and x equals negative 2. Look at that amount of work. But you might not know that. Opposite of 7, negative 7. Plus or minus. Square root of 7 squared. 7 squared is 49. 4 times 1 times 10 is 40. And then 2 times 1 would be 2. 49 minus 40 is 9. Square root of 9 is a nice even 3. And then either write the two equations, because we can combine the negative 7 and the 3. Either write both of them or do them both in your head. I'll write the equations here. Negative 7 plus 3 over 2 and negative 7 minus 3 over 2. So negative 7 plus 3 is negative 4. Let me get out of the way. Negative 4 divided by 2 is negative 2. Negative 3, or negative 7 minus 3 is negative 10. Divided by 2 gives you negative 5. Those are the same solutions we came up with originally. Negative 2, negative 5. If you can factor, you will save yourself time. All right, last one. This one looks a little strange. B, there is no B. No B. So we got to put in zeros. The A is 2, and the C is negative 19. I am so glad this problem is here. The opposite of 0 is 0. There's no negatives here. 0 squared is 0. Now, if your A or your C is negative, it's going to turn to plus, right? Because a negative 4 times another negative number flips it to a positive. So let's see, 19 times 2, or 19 times 4, 76. 76 times 2, 12, 152. So plus 152. Denominator 2 times 2 is 4. All right, the 0 plus or minus, whatever. We'll just write plus or minus. 0 plus 152 is 152. I write 4. Now, 152 has a factor of 4 in it, so it's 4 times 2 times 19 is 38. So if we were to break this up with radicals, 4 times 38, square root of 4 is 2, so we have plus or minus 2 root 38 over 4. And then we can simplify the 2 over 4. 2 goes into 2 one time, 2 goes into 4 two times. So we have plus or minus root 38 over 2. This would be our final answers. There's two answers there. Positive root 38 over 2 and negative root 38 over 2. Now, if I saw this problem originally, if you're ever missing a b, and I say do it with whatever method you want, that's going to be easiest to solve with the square root property. So 2x squared minus 19 equals 0. If you were solving that with the square root property, first you'd add the 19 to the other side. Then we would divide it by the 2. X squared equals 19 over 2. And then we would square root. Did I fudge something up here? Yeah, probably. So if you square root both sides, oh no, we're good. You would have plus or minus root 19 over root 2. And then you gotta rationalize that denominator. So maybe this wouldn't have been super helpful to do it this way. But it is an option. And this 19 times 2 would give us root 38. Root 2 times root 2 on the bottom would just be regular 2. Does it save work on this particular problem? I don't know. But you got two options still. So usually when there's no b, I like to solve it with roots. But I mean, that one, it was almost just as easy to do the quadratic formula.